We are going to be taking it one after the other in each video. So the first video that we are going to be doing is on site clearance, and after that we'll be going to topsoil excavation, disposal of topsoil, up till we finish formwork to edges of oversight concrete. So that's where we are going to finish on substructure, and after that we are going to move to superstructural works. For example, this side, let me just draw this side out. This side is like this. We have a column here. This is the column. You can see that I arched the inside. It's serving as, this is the column, starter column. This is the starter column, starter column. So this is where the starter column is going to be. Normally, when we are calculating for trench excavation, the width of trench excavation is 675. Is 675, but this pit excavation, the width of the pit excavation is going to be 1,200. It's going to be 1,200. And we say that this is going to be, normally it should be like this. From here to here is 675. 675. Please look at it, is 675 from here to here. But the pit that we calculated, we dug, is like this. Which is from here to here is 1,200. 1,200. So that's what makes it to be different. And when we are calculating, we say that we deduct internal part, we deduct external part. The only thing we deducted is from here to here. From here to here that we deducted. Check this place. From this place to this place, that's what we deducted. We did not deduct from this place to this place, from it. And it's going to be covering this place, this small part. That's what we now want to calculate, that is going to be deduction. And how are we going to get it? We know from this place to this place is 1,200. Is 1,200. So we have the starter column. You can see it from the slide. That's the column that is going to project upward. This is an example of the starter column. From here to this place is the starter column. From this place to this place is the starter column. From this place to this place is the column base. So we need to calculate the concrete from this place to this place. And how do we calculate it? It's very, very simple. We are given here. We know the height from here to here is going to be 1,200. That's the height of the what? Of the concrete in starter column. So we have that's 1.11/5.1.1.1. That's where you can find it. The first thing that we are doing there is maths. Maths. And you can find it in 1.11/35 because that reinforcement is under in situ concrete. So that's the reason why we are using it there. From this drawing, we can know the type of reinforcement that we are going to be using for the mats, the type of reinforcement that we are going to be using for the starter bar, the type of links that we are going to be using. Here it is stated that we should use 4y16. That means the diameter of the nominated size of that bar should be 16 mm diameter bar. Here the links, they say that 12y10, 12y8 should be used as link at 250 center to center. Here also they gave us that for the mat, this is an example of the mat. This is how it is done. They say that 10 number of y16 is for the mat. So we don't need to calculate very much because it is given to us. But if it is not given to us, there's a way to do it. I'm going to share it in the video also. So here, (1,300) as the length of that reinforcement. But mind you, the reinforcement is going to be going this side and this side. If you check the picture on the slide, you will see as the reinforcement bar is interwoven. There are two types of filling to excavation, filling obtained from excavated material, and imported filling. There are two different types of filling. This one is we are filling. If you check the slide, you see that there are differences. You are filling like the middle. For example, this. Let me just use this as an example. This is the place you have already excavated. You have excavated this portion, like this 675 that we've excavated. We put 225 block, 225 footing here. This is concrete footing. Concrete footing. We put block here. There's a block. Block is 225 also. 225. 225. So all this place and this place, we can't leave it empty. That's the reason why we have to do filling to excavation. It's different from filling with what? Filling with laterite. It's different. I've made it very simple because they gave you doors and window schedule. If they did not give us door and window schedule, we have to go to the window, to the plan, floor plan. We'll now be checking how many types of 200 2 windows do we have. 1, 2, 3. We'll not be counting it. But since they give us door, they give you door and window schedule. Don't disturb yourself. The door and window schedule will tell you how many numbers of 1,200 do we have, or window do we have, how many number of 900 door or 900 door do we have. So you don't need to disturb your. Just go to your door and window schedule. Just picking the number there. Don't need to count anything. But if it is not given, that's when you now be assuming. But in this case, it is given, and you see it from the slide. It's given. You will see it from the slide. So we have two types of window. We have two types of door. The first type of window is 1,800 by 1,200, and the second one is 1,500 by 1,200. So those are the two types of window that we have. And the first one, we have 6 numbers. The second one, we have 4 numbers. And also door, we have two types of door. 900 door, and the second one also is 900 door. But the material for the doors are different. That's just difference there. So you can use the same. You can just say that we have 4 doors. But when you want to calculate door, the door, that's when you now separate it. So let's go. Firstly, in this video, we are going to be doing rafter and purlin. The rafter, the only thing that we need for the rafter is in 1.16 or carpentry, other carpentry. So rafter, the first thing we need is we need the breadth of the building. The breadth of the building. That's what we need. And we know the length to be 19, and why this one is 9,225. You can check the foundation plan. You'll see it there. The length is 19,575, and the breadth is 9,225. So this being given, what we want to just do is we want to get the slope of the rafter. That's the first thing that we're going to do. We are going to get the slope of the rafter. After getting the slope of the rafter, we'll get the numbers of rafter. But the way the lecturer would teach you, if she's going to use the same pattern that she used for us, the numbers of tie beam should be equal to the numbers of rafter and the numbers of king post also. So the same number that we get used for tie beam will be the same number that we are going to use for our rafter, and it's going to be the same numbers that we are going to use for our king post. But if she says otherwise, please put that in the comment section, and I'm going to re-explain for you a better one. So the rafter, we know our breadth to be so this is our code. So we are through with our rafter, and the next thing we are going to be doing is our purlin. But we have some things that we are going to less. Checking the previous video of trench excavation you see that we'll less some things. We first less our external part. This one is 1,200. We are going to less external part, which is 1, 2, 3, 4, 5, 6, 7, 8. That's our external part. We have 1, 2, 3, 4, 5, 6, 7, 8. 8. And we have 2 internal parts. 1, 2. We have 2 of it. 2 internal parts. And we have 8 external parts. So less external part. And we're going to be doing the second question of the 2019-2020 past question. The question says, using the drawing numbers FUTA, take off for concrete works in superstructure. That's the question. Number 1 and 2 are compulsory. And within 30 minutes, you can finish 1 and 2. It is very, very simple to calculate. Take off for all concrete works in superstructure. What that means is that you are going to calculate for lintel, for beam, and for column. Those are the 3 things that we have. Lintel, beams, and column. We have only one beam here, the reinforced beam. We have column, which is 10 columns, and they are identical. They are the same size. So you don't need to disturb yourself about that. And you have our lintel. But in this video, we are going to do lintels first. But when you are doing concrete works, you should know that every concrete works has 3 things that you are going to do there. You are going to do the concrete, the reinforcement, and the formwork for every concrete works. So make sure that you do that, and you're going to have your full mark. For lintel, it is going to be easy for you to calculate it using your windows schedule, windows and door schedules. Everywhere you have windows and door, you have lintel. So just go to your windows and door schedule. You'll see it on the slide that I'm even using these windows and door schedules. That's what you just need. It will give you the numbers of windows that you have and the size of each window. So let's go. The first one that we have the concrete. Let's calculate the concrete. Ratio 2.1.2.2. That's where you find it in the BSM4 revised. The size of the formwork of lintel is meter. Why the soffit is in meter square. So take note of that. And in this video, we are going to be concluding the question 2 of the 2019-2020, which is concrete works. And the last thing is columns. And the columns, we are going to be doing the reinforcements, the concrete, and the formwork. Those are the 3 things that you must do. It is a must for you to do it in any if they ask you to do concrete works. And it is for the past 3 years they have been bringing it, and that's how it is being done. So for the concrete and column, that's the first thing. So the code is 1.11 ratio 34.1.4.1. So this is the end of links. And the last thing that we are going to be doing in columns is the formwork. We are doing question 3 of the past question of 2019-2020. And what's in it is that we should calculate all block work in superstructure. That's the question. All block work in superstructure, calculate complete the block work in superstructure. So what do you need for the block work in superstructure? You need the total GAT. You know, we've calculated the total GAT when we are calculating trench excavation. So the total GAT that you got, that you have not removed the external part, the internal part, and the T-junction, that's what you just come and lift. Just lift it here. That's what you need. For the block work is in the meter square. And meter square, we just need the total GAT and the height of that block work. What's the height of the block work? The height of the building is the height of the block work. And they say that we should calculate the block work in superstructure. So the height is 3 meters. That's what is given to us in this section, 3 meters. So we have the total GAT to be this, and the height to be 3,000. That's all about this block work. but there are still some things that we are going to remove from the block wall